Okay, we've looked at the cosecant function. Now we're going to graph the secant function. The secant function is related to the cosine function, like this. It's the reciprocal of the cosine function, so 1 over cos x. Looking at our table of values here for the secant function, we have over here in light gray behind the grid a y equals cos x graph from 0 to 2 pi. Just to show how it will be related. Again, we're looking at our unit circle. These are going to be the radian measures on our unit circle. We're going to find when we have cos of 0. So that's on the right hand of the unit circle. Cos of 0 is 1. So then we have 1 over 1 for secant, which would also be 1. So we have this point 0, 1 on our secant graph. So 0, 1. Okay, it shares that point with the cosine function. Pi over 2 on the unit circle up to the top of the circle. Cosine is 0. 1 over 0 for the secant is undefined. So you guessed it, there will be an asymptote there. The asymptote will be x equals pi over 2. Let's put that on our graph. Okay. At pi, to the left-hand side of the unit circle, cosine is -1. 1 over -1 for secant is also -1. So we have this ordered pair, pi, -1. So pi, -1. It shares that point with the cosine function. 3 pi over 2, down to the bottom of the unit circle. Cosine is 0 again. 1 over 0 is undefined again. So, yes, another asymptote. At x equals 3 pi over 2. So we'll sketch that in here. All right, 2 pi, back up to the same place as 0 in the unit circle. We have 1 and 1, because 1 over 1 is also 1. So we'll have this point here that it shares with the cosine function. All right, so then what happens? These are our 5 points that we need to be able to remember. So 5 key things to remember about the secant function. Just like 5 key things that we've memorized from every other trig function we've dealt with. We have 2 asymptotes. We're talking about the 5 key things in between 0 and 2 pi. So we have 2 asymptotes, and they are x equals pi over 2 and x equals 3 pi over 2. And we have 3 really good points, ordered pairs. Of course, there's an infinite number of other ordered pairs that are also here in between, but these are good values for us to remember. 0, 1, pi -1, and 2 pi 1. All right. From there, it takes the same shape as our cosecant function did. This graph down here curves down. This is a local maximum. The same thing then will happen over here. So if we think about just going to 2 pi, if we had a restricted domain, we would stop here. Restricted domain from 0 to 2 pi would look like this. All right, so those are the 5 key things to remember, and this is what those 5 key things would look like. All right, that would be y plus secant of x. Let's continue on the pattern. Again, this pattern starts repeating after 2 pi. So the period is 2 pi. So this will repeat up like this. And there will be another asymptote here. This will repeat up like this. Oops. And there will be another asymptote here. Okay, so let's talk a little bit about these 2 functions together. Some characteristics of secant and cosecant will be similar to cosine and sine graphs, such as the repeating pattern. And the repeating pattern we know is horizontally that's length in radians is the period length, and therefore the period formula for both of these graphs is just exactly like it is for sine function and cosine function. Period equals 2 pi over b.